Good morning to everybody. Today we will discuss classical electrostatics for MSc Physics semester 1st, unit 2nd. The important topic for exam point of view, that is boundary value conditions. To start this boundary value conditions, we obtain a important relations in between electric susceptibility and the dielectric constant for a dielectric media. Is on lower classes, UG classes, we have calculated the same, but here we are repeating only that one, and that the relations is obtained by using the induced polarization P for dielectric medium is given as terms of electric susceptibility P equal to epsilon naught chi E into the E. Here E is the electric field, P is the polarization vector, that is dipole moment per unit volume, and the chi E is electric susceptibility. And the electric displacement vector, as per we know very well for the medium, D equal to epsilon E. And also the relation between the D and P is given like this one, the D equal to epsilon E plus the P. So using the equation first, we have value, substitute the value of the P, epsilon naught E plus P equal to epsilon E, and on rearranging the value of the P, and we can obtain the epsilon by epsilon naught equal to 1 plus chi E, or epsilon by epsilon naught we know very well, that is known as the dielectric constant or relative permittivity, and that epsilon are equal to 1 plus chi E. So this gives the relation between dielectric constant and electric susceptibility for a dielectric medium. Now we switch over to our important topic, that is boundary value conditions. What is boundary value conditions? Means this gives the relations between the electric field, magnetic field, and the potentials and the gradient of this one at the interface of the two mediums. Here the interface is given in terms of the dielectrics. Means this gives the relations between the electric field component in the first and second medium having the different dielectric constants. So to obtain boundary value problems, we can use the method of images for dielectrics. Let us consider a point charge Q embedded placed in the semi-infinite dielectric medium with the dielectric constant epsilon naught, and this charge is Q is located at the distance d from the plane interface that separates the first medium from the other medium of dielectric constant epsilon 2. As shown in the figure, there is the charge Q which is placed at the d distance along the j directions, and here the dielectric constant is epsilon naught 1, and the other medium having that z is less than 0, dielectric constant is the epsilon 2. So now to obtain the boundary value conditions, we use this figure. So for the first medium, we can use Gauss law, del dot E equal to rho by epsilon 1. Rho is volume charge density, and this is for z is greater than 0, means z positive के लिए ये value satisfy होगी. And for the z negative, we can obtain, because in the second medium there is no charge density, so the del dot E equal to 0 by epsilon 2, and this is for z is less than 0, and this will give the 0. And for the remaining components, we can use the conservative nature of the electric field del cross E equal to 0. So for the x and y components, we can use del cross E equal to 0. And for the z components, that is normal components, we can use the boundary value conditions for the d2n minus d1n equal to the sigma f. That is the displacement vector relations between these two, that is epsilon 2 Ez minus epsilon 1 z equal to the sigma f. So at z equal to 0, because there is no free charge carrier, so we can write epsilon 1 z Ez equal to epsilon 2 Ez, and that is for the first media that is greater than 0, and for the second media z is less than 0. And for the tangential components x and y, we can write E1t equal to E2t, like Ex equal to the Ex for the both mediums, and similarly for the Ey equal to the Ey for the both mediums. For the Z is less than 0 and for Z is greater than 0, we can write. So these are the three boundary conditions, relation between the electric fields components along the X, Y and Z. Here that is the continuous for the X and Y, Ex equal to Ex for the first and second medium. Similarly for the second, Ey, and for the third components, that is the relations for the electric displacement factor is satisfied for this one. Epsilon 1, that is we have write epsilon 1 Ez equal to epsilon 2 Ez. Here the Ez have the different values. Now for the calculate the boundary conditions for the potential, we use method of images. Here the interface is again at the Z equal to 0. For the Z is greater than 0, the medium is epsilon 1, and the for Z is less than 0, medium is epsilon 2, and the source charge is Q plus at the 0, 0 D, and the image charge is at the 0, 0 minus D, that is Q dash. Now at the point P that have the coordinates x, y, z, we want to calculate the potential. So the distance between the P to A is the R1 and the P to A dash is the R2. So the potential at point P x, y, z लिखें या इसको रो या R, phi, z लिखें स्फेरिकल कोऑर्डिनेट सिस्टम में, सिलेंड्रिकल कोऑर्डिनेट सिस्टम में किसी में भी लिख सकते हैं. So the for the point P we can write phi equal to kq by r1 plus kq dash by the r2. Here the potential is calculated in the first medium, so the phi equal to 1 by 4 pi epsilon 1 q by r1 plus q dash by the r2. Here the r1 is x square plus y square plus z minus d square, and the r2 equal to x square plus y square plus z plus d whole square and root of this one. So this is given by the boundary value conditions. So potential is given like this one, phi equal to 1 by 4 pi epsilon, please correct it, this is not epsilon naught, this is epsilon 1. Phi equal to 1 by 4 pi epsilon 1 q divided by root of the x square y square plus z minus d का whole square and root of all plus q dash root of the x square plus y square plus z plus d का square. So above equation is the same for the earlier problems as earlier we have calculated for the method of images, where we have considered the conducting materials for the z equal to 0, but there is the dielectric medium epsilon 2 for the z equal less than 0. Yes, there's negative regions, that is the second medium is there, so it must follow the Laplace equations, that is square phi equal to 0. So it is simplest assumption that the for z is less than 0 we have to calculate potential is equivalent to the charge q double dash is placed at the position A in place of the charge q dash q. So here we have assumed that whole of the space is filled with the dielectric medium of the epsilon 2. What we are doing, see this one, we want to calculate the potential at point P due to the second media, that is z is less than 0. So for this one we have assumed that the charge is replaced, q is replaced by the q double dash in place of the media epsilon 1, the dielectric constant is replaced by the epsilon 2, so same conditions is used. So phi for the less than z less than 0, 1 by 4 pi epsilon 2 q double dash by the r1. So now to calculate only relations amongst q dash and q double dash relations, so we must satisfy all the boundary conditions for the electric field components. At z equal to 0 potential is continuous, so phi z equal to O 0 plus and equal to the phi z equal to O 0 minus means second regions. हमने z component लिखा था epsilon 2 z for z less than 0 equal to the epsilon Ez z is greater than 0. So we know where that equal to minus del phi. So phi is given at the 1 by 4 pi epsilon q by the r1 plus q dash by the r2, and if we are want to calculate the differentiate this one with respect to z1 by r1, so del by del z सब्स्टिट्यूट किया हमने, सारा वैल्यू कैलकुलेट किया तो लिखा हमने कि 1 minus 1 by 2 into z minus d divided by x square y square plus z minus d square power 3 by 2 for the z equal to 0. This is only and only plus d divided by x square y square plus d square 3 by 2. So we have right here epsilon 2 multiplied by 1 by 4 pi epsilon 2 q double dash d divided by x square y square plus d square power 3 by 2 equal to epsilon 1 multiplied by the 1 by 4 pi epsilon q d divided by x square y square plus d square power 3 by 2 minus q dash d divided by x square plus y square plus d square 3 by 2. So this gives the values q double dash equal to q minus q dash. And for the tangential components, for the second one we can write ex equal to ex. Here z is less than 0 and z is greater than 0. So 1 by 4 pi epsilon 2, and this is q double dash minus x divided by something equal to 1 by 4 pi epsilon q something. So this gives q double dash by epsilon 2 equal to q plus q dash epsilon 1. So now to calculate the value of the q dash and q double dash in terms of the q, we can write simply rearrange these values. Q dash gives epsilon 1 minus epsilon 2 divided by epsilon plus epsilon 2 multiplied by the q, and for the second q double dash equal to q minus q dash, and this gives q double dash equal to twice epsilon 2 divided by epsilon 1 plus epsilon 2 multiplied by the q. So this is the tricks by which we can calculate the image of the given charge which is placed for the dielectric media. So today is sufficient. Thank you very much to all.